welcome. Thank you so much for joining me. When we look at matter and energy and how matter and energy interrelates with one another, we're really looking at that core of chemistry, and in a sense, the essence of what we will be exploring in chemistry. Matter transforming into matter, matter interacting with energy, releasing energy, absorbing energy in all sorts of ways, shapes, and forms. So let's make sure that we understand those foundational aspects of energy. Kinetic energy. Energy overall of a physical system is the ability to do work. So energy can exist in several forms, including mechanical energy, heat energy, bond energy, light energy, electrical energy, and so forth. Now, the first law of thermodynamics states that energy cannot be created nor destroyed, just like the conservation of matter. We cannot create nor destroy matter. We can, however, transform it into another type of energy. So energy can be transformed from one type to another type. So we can go to radiant energy to chemical energy to energy of motion, electrical energy to thermal energy, for example. So there's quite a few forms of energy, but overall there are two broad types of energy: kinetic energy and potential energy. Now, kinetic energy, I think, is a little easier to wrap your mind around in chemistry than is potential energy. Potential energy can be challenging, and I'll be addressing that in a different video. But if we look at examples of those: kinetic energy, energy of motion, light, sound, heat transfer, mechanical motion; potential energy, we've got chemical energy, nuclear energy. And this chemical energy we have to be really careful of, and I want to address that in more depth, so to speak. So let's take a look then at a little more detail on kinetic energy. Kinetic energy is overall kinetic energy of motion. Molecules move. Molecules bump into one another. So when calculating that kinetic energy, the formula is 1/2 mv squared. And m is our mass. And we would be talking, if we're going to use kinetic energy, we want to use our SI units of kilograms, and we would typically do it on a per molecule or per atom basis. V is our velocity, and our SI units would be meters per second. So if we plugged into that formula, we'd have kilograms, and we would be squaring the meters per second. So we'd have kilograms times meters squared over seconds squared. And that derived unit is also known as a joule. So the joule would be our SI unit for energy. Now, a lot of students don't really totally get that connection between heat, kinetic energy, and temperature. And what we find is that temperature measures average kinetic energy. So it's not measuring an exact kinetic energy. If I could look at the fraction, the number of molecules and their kinetic energy, it would be what we call a Boltzmann distribution. Okay? And so if we have T1, if we increase the temperature, that's going to shift over so that on average, more molecules have higher kinetic energy. And that's when T1 is, excuse me, I almost made a mistake there. T1 is less than T2. Okay? So T1, the way you could write that is temperature is a measure of the average kinetic energy. You might put a bar over it, or sometimes you may even see the word AVE there. Okay, so what that means is that the higher temperature that we're measuring is the result of the greater kinetic energy. Okay, now let's bring that. So that's how temperature and kinetic energy relate. Let's bring heat into that conversation. Heat is given the symbol, because symbols have meaning and there's lots of symbols in chemistry. It's given the symbol Q. Okay, and that's often known as thermal energy. And heat is not something that just exists. Heat is a transfer process. So as molecules collide and get near one another, there's a transfer of kinetic energy. And your fast molecules are always going to be transferring heat over to the slow molecules until everything reaches like a thermal equilibrium, where the average speed overall of the molecules no longer changes. So we always transfer heat from higher temperature to lower temperature because we're always going from higher kinetic energy to a lower kinetic energy. So we always transfer heat from high temperature systems to low temperature systems. So when you touch a substance and that substance is hot, its molecules are colliding with your hand and transferring energy to your hand, and that's going to raise the temperature that you would measure of your hand. Okay, so that's the difference in heat, kinetic energy, heat, and temperature. Now, how do we transfer heat? Well, there are three main ways to transfer heat that we would look at this level. And the first is conduction. In conduction, you have direct contact. Okay, so they're brought into direct contact with one another. They're touching. So if you grab a beaker that's hot, and by the way, in our lab, you won't be getting glass hot enough to see its color change. So hot glass looks like cold glass. And if you touch a hot beaker, you're going to burn yourself. That's conduction. Okay, convection, and this is often, boy, heat change through steam can be really, really painful. Okay, convection is the transfer of heat through a fluid. Okay, so in this case, you have the convection as you go from, they don't have to be in direct contact with one another. It's due to the circulation or movement of molecules through a gas is often what happens, like in convection ovens. And then we have radiation, in which energy, and this is a key one. I would say this is probably, those are the two probably key ones we'll come across mostly in chemistry. And the interaction of electromagnetic radiation or light waves with matter is a critical component of the instrumentation that is used to study matter, study the structure of matter, study interactions in molecules, study changes in matter. And so that's going to be a very important one, as you will see as you continue your journey in chemistry. So thanks for joining me in this quick introduction to energy.